Okay, this is what's called a dewar, and the dewar is used to contain the liquid nitrogen. The liquid nitrogen is so incredibly cold that if you were to put it in any kind of regular container, that container would cause the liquid nitrogen to evaporate very quickly. So the dewar has these extra layers, and those layers work to insulate the liquid nitrogen against the environment. Notice it's got a foam top, and this doesn't make a very good seal, right? So it's not airtight, and that's by design. Anytime you have something that's going from one state to another, you can cause a pressure change, right? As we go from a liquid to a gas, the gas takes up more pressure. So you don't want this sealed tight, because then you could have an explosion, right? Anytime you have increasing pressure inside a sealed container, that's a recipe for disaster. So you also may notice, so look at what I'm wearing today. I'm wearing sandals and shorts and a t-shirt. Now, this is not proper lab attire, but there's a reason for this. There's an effect called the Leidenfrost effect. When you're dealing with really hot or really cold substances, when there's a huge difference in temperature, the energy difference causes an immediate phase change. So liquid nitrogen, although it's cold enough to freeze my hand off and really damage my skin, it'll only do that if it stays on my skin for a long period of time. So this liquid nitrogen is at roughly about negative 300 degrees Celsius. It's extremely, extremely cold. If I pour some of it on my hand, it's going to immediately form a vapor and fall off my hand. So you can see there, I get a little bit of a sting as it starts to freeze parts of my hand, but it doesn't stay there long enough to actually cause the damage. So if liquid nitrogen hits your skin for just a little bit, okay, and it rolls off, it's not going to damage your skin. The problem is when the liquid nitrogen has some place to sit and hold around for a while, and if it can sit next to your skin, just like with something really hot, it's going to do more damage that way. So I'm not wearing much protective gear, because if I get this on me, what I want it to do is just fall off me real quick. So I don't want to wear pants, I don't want to wear shoes, because I don't want anything that can fall inside. Okay, so here's my bottle of soda, replaced with a little bit of water. I'm going to pour the liquid nitrogen into the bottle of soda, and when I turn it upside down, that's when we're going to get the reaction. So I'll come back in just a moment, and we'll do that experiment. Okay, here we go. So I've got my liquid nitrogen, and I've got my bottle of water. Okay, so I'll do this out here so you guys can see it. Alright, so I'm going to pour some of this in the bottle of water. We don't have a violent reaction until I invert it. So when I pour it in, it's going to make foam on top. But otherwise, it's not going to mess with it. Well, once I turn it over, here we go. And you get a rocket. Alright, so here we go. Let's go and do it one more time. So I'm going to pull the liquid nitrogen out of my dewar. Let's dump off a lot of this. I don't actually need this much. There we go. Okay, so here's the liquid nitrogen. Remember, negative 200 and maybe about 300 degrees Celsius. Incredibly, incredibly cold stuff. And a bottle half full of water. Think about the equation, force equals mass times acceleration. If you want to know how much acceleration you're going to get from this experiment, you have to take into account the mass of the bottle. I want you guys to think about, would having more or less water in here make this bottle go higher? So I'm going to walk back so you guys can see. Okay, so pour the liquid nitrogen inside the bottle. Okay, now that it's in there, as soon as I shake it up and turn it around, and it's gone. It's in the neighbor's yard.